All right, and thank everyone for coming here today. So, as he just said, I'm going to be talking about security policies today. And security policies are one of those funny things where if you use the term security policy, you probably have a pretty good idea of what you mean. But if you ask 10 different people to define security policy, you're probably going to get 10 different definitions. So I'm going to spend a little bit of time saying exactly what I mean by security policy and security manager so that we're all on the same page as I dive into this. And as I go through that stuff, it's going to apply to application and application security in general. But I'm going to pretty quickly get into some specific examples and talk about Java web applications. And so once I go over all that stuff, then I'm going to start talking about how these security managers and security policies are being used in practice today. And in particular, how they're not getting used, and sort of go into some of the reasons on why that is. And finally end by talking about Pi, which is an open source project I've been working on to try to alleviate some of these problems with managing security policies and with writing them so that hopefully it can help make these tools easier to use and help make applications more secure. So what is a security policy? So at a very high level, a security policy defines resources of an application and defines what is allowed to be accessed and under what context. And so context can mean a lot of different things depending on what the security policy is that you're talking about. And it can be something like what the user is, where the request is coming from in terms of IP, internal, external. It can be a lot of different aspects of what the context is. But generally, it's just what resources can be accessed. And so if you think about an ideal, simple security policy for maybe something like an online financial application, it could look something like this, where you've got 4 different resources, and depending on what role a user is logged in as or whether they're authenticated at all, they might have access to these different components. In practice, this starts getting more complicated because you don't just base your decisions on the user's role. It might be based on something like whether they're internal or external. And so you start having this sort of more finely grained security policy. And before long, you realize it's not just about what the user's role is, it's also about more specific details on these application resources. So whether it's a public or private stock, whether you're talking about beta features or something that's already been released. So all these different details come into play as you start developing these security policies. And I just sort of generated this access control matrix based on what seemed reasonable to me, but you can imagine what this begins to look like as you implement it in code, and it's going to end up being scattered across a lot of files and really hard to figure out whether your code matches this policy, and also probably pretty difficult to even figure out whether this policy is actually the business logic that you want. So this is just kind of motivating the idea that before long, in reality, security policies are going to get pretty hairy. So a security manager is something that takes in a security policy defined in whatever context you're speaking about, and then is responsible for enforcing that security policy. So there's a lot of different examples depending on your context. If you're at a database or file system, this can be the actual file system driver or the database driver. On a firewall, this could be software or hardware rules actually enforcing those IP tables or whatever your firewall is. The Android permissions framework is a great example of a security manager. You define your security policy in your application's manifest, but then it's the actual Android kernel that's responsible for enforcing those policies. And then getting a little closer to actual application policies, there's content security policy, which is implemented in user browsers. There's the Java Security Manager, which is a component that lives inside the JVM. And then there's Spring Security, which is a Java framework for actually implementing various web security tools. And I'm going to go into a little bit more details on those last 3 just because, as I said, I'm going to get into some very specific examples going forward. So content security policy is a defense in depth solution that's implemented in browsers to try to mitigate and eliminate cross-site scripting. So the way that works is that the server sends information in the response header saying what origins different resources can come from. And since in principle, usually things like scripts and CSS are static files, if you're only retrieving those from trusted sources, then you can't get cross-site scripting injected into your page. In practice, your CSP policy can also say that you can do things like run eval, which then means that you can still execute arbitrary code, but a strong CSP policy can reduce or eliminate some of the cross-site scripting vectors. So the Java Security Manager is something that's been in the JDK since the beginning. So it's been in there since version 1.0. And the most common use case for the Java Security Manager is to sandbox untrusted code. And you see this come up in, for example, web applets. If someone's got a Java application on a web page, then there's a Java Security Manager in place to make sure it can't do things like read files and then send that data back off to a server somewhere. So it's very often used in cases where you don't know what code is doing and you want to make sure it's only doing authorized things. So the Google App Engine, which hosts Java web applications for you, also uses a security manager to sandbox the code that people upload. But it doesn't have to just be used on untrusted applications. It can also be used on code you trust to just make sure it's not doing anything you don't expect it to. It can reduce what sockets can be opened, what files can be accessed, what files can be executed, and various things like that. So it's got a very granular permission set that you can specify as part of the security policy and really sort of lock down and get very finely tuned controls on your application. And then the last example that I brought up on the earlier side is Spring Security, which is, as I said, a Java framework that can do a lot of different things. It's got a lot of customization and supplies a lot of protections to web applications. And the one thing about it that I really, really like is that it's got support for putting annotations on methods and defining method-level access controls that you can then hook into your security policy and define what users, what roles, what IPs can access certain methods. So if you think about something that's sensitive, like credit card data, you can put an annotation on your get credit card number on the model for credit cards and specify which users can access that method. So there's ways of getting really finely controlled security that is specific to your application with a tool like this. So in general, the security managers enforce policies and often add an additional layer of protection on top of your applications. And when they're utilized well, they can mitigate or entirely eliminate some of these really common classes of vulnerabilities. And so if these things are so great, we should be using them, right? Well, let me give you a use case of somewhere where this would help. So Struts 2 is a web application framework that has been plagued by remote code execution vulnerabilities. It's had over 12 of them in the last 5 years or so. And they're all related to injection into OGNL, which is this object graph notation language that Struts uses as a way of sort of dereferencing fields within its object models. And so there's this web blogger called Roller, which happens to use this vulnerable framework. And because it happens to be using this vulnerable framework, all you need to do is pass a particularly crafted requests and get remote code execution. So if you just run this HTTP request, get requests, it will pop up a calculator on your screen. And that's bad. So the first pass at fixing this vulnerability involved blacklisting characters that you would use on this attack. And that blocked the one particular vulnerability that they knew about, and they immediately found out that this was not sufficient. The excluded parameter pattern did not cover other cases. So they did another pass at it, and at this point, Struts is using a regular expression to whitelist allowed characters in there. So better, whitelist is better than blacklist on allowed characters, but it's still just a matter of regular expression matching the input data and then passing it to this really powerful OGNL language that has the potential to execute arbitrary code. So if you're supporting one of these legacy Strut2 applications that's old and you can't upgrade your version of struts, you're stuck with this potential issue of your application has a remote code execution vulnerability. So what do you do about it? You need to have some extra layer of protection on top of your application. And in reality, supporting legacy applications is something that we have to do. And even though this current version doesn't have any known exploits, as I said, it's just using a regular expression to whitelist characters before passing it on to this OGNL framework. And so how confident are you that there's still no way to craft a response that can execute arbitrary code? It would be great to have an additional layer of protection to know that you're probably less likely to get one of these remote code execution vulnerabilities. So this is, I think, a very good case for using something like the Java Security Manager, which has lots of layers in this finely grained permission model to prevent these kinds of vulnerabilities. So you can finally specify which OGNL directives you're allowing, whether you can set the class loader, whether you can access and execute certain files, and all these things that you need permission for in order to do one of these remote code executions. So that's a perfect example of why I think we should be using these security managers. They can protect legacy code, and they can even protect you against vulnerabilities you don't even know about. And they've been around for 20 years, if not longer. So every web application uses these tools, right? No, you've probably never even heard of some of these things I'm talking about. So let's start by talking about CSP. So before I came over here to Amsterdam, I ran a script on the top 500 websites and looked at the response headers to see which are using CSP. And only 2.7% of them sent back a response to say they're using CSP. And even among those that are, more than half of them use this unsafe eval or unsafe inline directive, meaning that you can still run pretty much arbitrary code on those sites that are using CSP. And there's a good reason for that. Lots of legacy code uses inline or eval, and lots of frameworks use these things. So it's better than having nothing, but in reality, just supporting these old code bases means that you're going to be using this sort of weak security policy. And if you search around a little bit, find some blog posts, people have done a lot of studies on how prevalent is CSP. And the suggestion is that it gets even worse after you get past those top 500 sites. Very few sites in practice are using CSP. So the Java Security Manager is, again, used in a lot of places that we know about as a sort of sandboxing mechanism, but its prevalence is a little hard to measure because it's sort of something that runs on the server side to protect the web application there. There's no sort of fingerprint to decide whether these sites are using the Java Security Manager. But I've talked to a lot of people about this since I started on this project, and no one I've talked to knows of a case where the Java Security Manager has been used on top of trusted code as a layer of protection. And if anyone here happens to have heard of a case of this, I'd love to talk to you afterwards, because this is just not even something I've heard of people doing. So as far as I know, this is, again, something that's not being done. And yet, for example, in the case I was talking about with struts, it gives you this great layer of protection whether or not you know about vulnerabilities in the frameworks you're using. So the question is, if these tools are so cool and so good, why aren't we using them? And one of the first answers I hear people give is that it impacts the performance of the application. If you're doing all of these additional permission checks and security checks, then it's going to slow down your application. And of course, there's no such thing as a free lunch. There's going to be some performance impact. But based on research people have done, it's not big enough that you should really be that concerned about it. So a paper from over 10 years ago studied the Java Security Manager in particular and showed that there's a 5 to 100% slowdown in resource requests when you're using the Security Manager. And that sounds really high, like 100% is not good, but that's per resource request, not per request, not per web request. And if you think about the density of resource requests within a typical application, you're not reading and writing files that many times within a given request, or even as much of a given request. And this also doesn't even count for things like network overhead that are going to be involved with your response time. So when you factor all of that stuff in, the actual impact of using a security manager is pretty minimal on the actual response time of a web request. And similarly, the developers of Firefox over at Mozilla have done benchmarks on the effect of CSP. And a very recent blog post says that we recently did a lot of work to improve the performance, and it's down to 0.02 milliseconds per resource load. And considering you've probably got at most a few dozen, like going, with your really dense websites, maybe you've got a couple hundred resources in a given page, that's still only a few milliseconds. And if that's the thing that's preventing you from using these security tools, I think your priorities might be due to be reevaluated. Sort of a couple milliseconds to prevent XSS across your application is probably not the reason that you're not using CSP. So the other reason I hear people say is, it's just hard to use these things. How do I write a policy for CSP, for the Java Security Manager? How do I use Spring Security? How do I know what permissions need to be added? Any good security policy is going to be a whitelist, and so you need to know all the permissions that your policy needs. And if it's a good policy that's granular and doesn't grant too many permissions, it's going to be specific to the different pieces of your application, whether that's per page or per class or per package. You've got to know what things each part of your application needs. And then, assuming that you've done this effort of creating a policy, how can you decide whether or not your policy is correct? I spent some time trying to make a CSP policy for an application I was working on, and I came across a web request for a resource on this something.cloudfront.net, and I'm like, is that actually a hard-coded host name that's always going to be requested as part of this application? Or is that sort of a randomly generated host name based on my location that has something to do with geo IPs, and I don't know. So should it be star.cloudfront.net? I didn't know when I was writing this policy. It's hard to decide whether or not what you come up with is going to end up breaking your application. You don't want to do that. That's not what you want. That's not what your developers want. And people are going to be unhappy if you're breaking their application to supposedly gain security. And then assuming that you have figured all that stuff out, how do you keep it up to date? What happens if a developer changes the resources that they're loading? What happens if you end up changing APIs or changing what third-party resources you're pulling down? If you upgrade a dependency, is that going to change all the package names that you are granting permissions to? If you put in all this effort to make a good security policy, you want to make sure that you're going to be able to actually utilize that effort and continue using that policy in future versions of your code. So these are all reasons that I hear on why we're not using Security Manager or CSP. And so just to walk through an example to really motivate, I think, why this is a problem. Tomcat, the developers, have put in a lot of effort to make a really sane default security policy that ships with Tomcat. And all you need to do to turn it on is pass this -security flag when you start up Tomcat. And it does a lot of cool things like grant the proper permissions to the container itself while isolating all the web applications you might have in there and making sure that they don't interact in bad ways. And so I decided to try doing this with a different Java web app called Pebble, which is just another blogger. There's sort of nothing particularly special about it. It's just this kind of neat, simple web application to try using with this Tomcat Security Manager. So I turn it on, I go to Pebble on my local host, and I get a 404. What's that about? Well, it probably means that something went wrong as the application was trying to start up. So I open up Tomcat's logs, and what do I see? Sure enough, there's a big stack trace in there. And your eyes probably glaze over a bit, and you're just like, I can't even read any of that. What am I supposed to get out of this? So if you squint hard enough, you might find the important things. Somewhere at the top, you can see that there was some exception with runtime permissions, and it got denied access declared members. And one of the classes in the stack trace is this class from Spring. And if you are familiar with Spring, Spring does dependency injection, so it auto-wires in the things you need into private and protected fields of classes. So it makes sense that Spring needs to be able to access private fields on classes. So, all right, that makes sense. Let's find out what access declared members means just so that I actually know what it is. You stick that into Google, you find the Java docs, you read it, you're like, I understand why this is here, I understand that Spring needs this, so let me add that to the policy. So you go to Tomcat's default policy and it tells you this. This is what you need to add policies to your web application. And if you look at this bit, this is a code base that specifies that you're granting permissions to classes within your application, as opposed to this line, which is granting permissions to different jars contained as dependencies of your application. And then there you also have to specify the class name of the permission you're adding, as well as these potential other parameters. So you've got to sit there and figure out what all these different pieces are that you've got to add to your application. And we saw that there was this runtime permission and access declared member, so we've got a good idea of those last two, but what code base are we supposed to be adding this permission to? I've been saying Spring a couple times, so we want to add it to Spring, right? Well, if you look at Pebble's dependencies, there's a Spring core. That seems probably like what we want, unless it's this Spring security core jar. Or maybe it was the Spring web jar that's in there, or Spring security web, because it's got something to do with security, right? Or context, which is the thing that actually auto-wires that stuff and is aware of your different beans and so forth, except that there's also this Spring beans, which has something to do with auto-wiring. And which of these jars are you supposed to use? Well, maybe it's Spring AOP, or Spring ASM, or Spring TX, or Spring Expression, or Spring Security Config, or Spring OpenID. But there's 12 Spring jars in my web app. How do I know which Spring jar I'm supposed to add this permission to? So I honestly have no idea how you're supposed to figure this out. And if you pray to the right oracles, they might tell you that what you need to add to your Spring or your Tomcat policy are these permissions to these 5 jars. I don't even know how you're supposed to figure that out. But if you add that in, you get past this stack trace, and you can restart Tomcat, and you still get a 404. So the process of building this policy looks something like this. You get your 404, you dig through Tomcat's logs, you look up the Java docs to figure out what permission you need to add, you figure out how to add it to your security policy, you restart Tomcat, and you still get a 404. And just to get Pebble to start up, you have to do that loop 84 times. And each time you do it, you have to figure out which of these 16 jars in its lib directory you're supposed to be adding that permission to. And at this point, that's just to start up the application. That's not even to do things like access files or upload files or any of these things that you're going to do when you actually start using the application. So you do this once, and it is no surprise that no one does this in practice. It is a painful process, and by the time you're done with it, you probably have no idea whether you've got a decent policy that works. So to try to do something about this terrible process, I've started working on this project called Pi for policy instantiation and enforcement. It's an open source project, it's on GitHub, and the idea is to just simplify and automate this process. So I'm going to spend pretty much the whole time talking about how to use it with the Java Security Manager, but it's something that's modular and works with security policies in general. So it also works with CSP out of the box, and there's some examples of using it with Spring Security. And so what is Pi? Pi, first of all, has a learning mode, and it does something similar to like SE Linux if you've used that, where it watches your application run and will automatically figure out what permissions it needs to generate in its policy so that it can add a layer of security to your application. So the second thing that it does is after looking at all of these permissions that your application will need to run, it then uses various heuristics to simplify and generalize that policy so that it is sort of simple and easy to understand and easy for a human to then look at and decide whether or not this policy has sort of any tweaks that need to be made to it. And the last thing that I've done with Pi is add this Maven module so that you can make it part of your software development lifecycle to test your application, to rebuild your policy, and to keep it up to date as you make changes to your application. So to go into a little bit more detail about how this works, suppose you've got your web application sitting in some container like Tomcat or Jetty or whatever you're using, And the JVM always has this Java Security Manager built in there, but generally it's probably not activated. So you drop in Pi, and it turns on the Java Security Manager. And anytime the Java Security Manager needs a permission, it will ask Pi for permission to grant that to your application. And Pi will just always say, yes, you can have that permission. It's not going to break your application. At this point, it's just learning what permissions your application needs. And so as this goes along, it generates a policy, and it outputs that and saves that somewhere that you can then look at or even just accept as it is. So when it comes time to actually enforce the policy, Pi will read that in, and every time the security manager makes a request, it'll say yes or no, depending on whether or not that permission is granted by the security policy it generated. So I gave that at a high level. Specifically, how do you do this? If you're using something like Tomcat, all you need to do is drop the Pi jars into your lib directory or add them to your class path somehow using Servlet 3.0 auto instantiation service magic. It'll automatically pick this up and it'll do its thing. All you need to do is drop those jars in there. So then you load up Pebble or whatever your application is, you run tests, you run your browser so that you're exercising the application, and it makes a policy. Simple as that. And so this is the policy that automatically got generated for Pebble. And you can see that it's got permission to read various things in its home directory. It can upload and delete files from its theme where you can add custom images and things. And you can also see down here this access declared members that we saw earlier. So it picked that up as well. So this is the sort of policy that it generates. And so the second thing I mentioned that Pi does is simplify your policy for you. So if you were to just let Pi run and have it just verbatim output everything that it saw that you needed, you would see a policy like this. And it turns out that Pebble, when it uploads files, it gives everything names with incremented numbers. And that's not very good for you, because if you test this and upload 100 files and then deploy the security policy to production, when someone uploads a 101st file, you're going to get a permission denied, because this policy doesn't let you write to file upload 101.temp. So what Pi does is it's got context-sensitive heuristics, and it sees things like file paths and sees that you've got a bunch of files in some directory, so it'll just collapse all of those to /star. And when you run the simplification on the policy generated for Pebble, before the simplification, it's nearly 1,800 lines, and afterwards it's only 80. And if you're going to look at one of these policies and decide whether it's correct and whether it's doing what it's supposed to, I definitely want to look at the second one, because I don't even think I can keep enough of the first one in my head to decide if that's correct. So I think this is also a very important feature of making a security policy, both because it needs to not be too stringent, it needs to have some generality to it, as I just described with these file permissions, and it also has to be easy for someone to look at and audit. So let's say you've done all this work, you've built the policy automatically so it's not too restrictive, you know all the permissions it needs, it's not too permissive, you haven't added a bunch of extra things to it, and by the time you finish doing this, your developers are on the next release, so your policy is already out of date. How do you deal with that? So the last part of Pi that I've already mentioned a little bit is a Maven plugin to make Pi part of the software development lifecycle so that you can both validate and update your policy automatically. You're already testing your application thoroughly with every release, right? You've got great coverage and you know there are no bugs in your software, so why not test it with your security policy? So all you need to do to put Pi as part of that test build is drop in the plugin, tell it where your server is and where your configuration is, and then run your test as usual. So Pi doesn't do anything at first. You just start running your test however you usually do them, whether you're running Selenium or some other framework that exercises your application, Silk or whatever you're using, and have that exercise the application. Pi will sit in there, you leave it in report-only mode so that it doesn't break your application. So it's not going to fail your build just because the policy was wrong. It's not going to start making tests fail left and right. But it is going to see any violations that are occurring. And so what the Maven plugin does is at the end of all your tests, it'll call out to the Pi module in the server and say, what violations did you see while you were running all the tests? And it'll automatically build new policies for you. So you don't even need to go through that whole original process of generating a policy to begin with. It can just see what's new about violations and update the policy. And so, and optionally, you can have it fail the build without failing any of those individual tests, so that you know that you need to then redeploy with an updated policy, but you don't need to go figure out whether your test failed because something's actually broken in the application, or was it just the policy doing something wonky. So cool, I spent a lot of time trying to talk this up a little bit, and the question is, can you actually try Pi out? Can I use it? So as I said, if you're using something like Tomcat or Jetty, all you need to do is drop it in, and if you're using a relatively modern container, it'll automatically find it and put it in there and start generating a policy for you. If you're using something like Drop Wizards, you just need to add one line of configuration so it'll pick it up. And it's using standard interfaces, so pretty much any Java web app, you can drop in Pi and use it pretty easily. As I said, it's more generic than just the Java Security Manager. It also works with CSP, so it does something similar where it will just drop in a filter and add CSP headers and see all the violations that the browser sends back and automatically build up a policy from that. And if you have something application specific, if you're using something like Spring Security that ties in users' role, what IP they're coming from, all these other different features that define a security policy, you can customize Pi and build this custom module that still uses all these features of the Maven plugin and the automatic simplification, and make it very specific to the requirements of your application and your particular security policy. So let's go back one more time and talk about that struts2 vulnerability I talked about, and talk about what happens if we use Pi. So you set up a Pi config, put it in learning mode, which is its default behavior, so this first line isn't even particularly necessary. You start up Pebble, or sorry, this was Roller. You start up Roller, you run your tests, you do whatever you want to exercise the application, you shut it down, you put Pi into actual enforcement mode, you start up Roller one more time, and now you try to run that exploit, and nothing happens. No calculator pops up, and if you look at your Tomcat log, it'll say, we saw a violation, permission was denied to do this particular OGNL directive. So Pi, without having to know anything about OGNL, without knowing anything about struts or anything about that particular vulnerability, blocked the remote code execution. And so if there's another remote code execution in struts, one we don't even know about at this point, Pi can protect you from that sort of thing without even knowing about it. So what do I want you to take away from this talk? The main thing is that these tools exist for building security policies and securing your app against both known and unknown vulnerabilities, but they're not getting used. And I think we as an industry should be asking, why is that? If CSP and the Java Security Manager have been around for so long, why aren't we using them? And my hypothesis as I've been working on this project is just that these tools are not easy enough to use. Even among security experts and among the developers of applications that understand these things, it's just difficult to do. And so my attempt to address some of these difficulties is Pi, which is an open source project. It's on GitHub, it's in Maven Central. So try it, use it, fork it, provide pull requests, let me know what you think of it. So that's all I've got. Thank you. So I think we've got a few minutes if anyone's got questions.
If I integrated this into my Maven build process, if I was doing security testing as part of that as well, might I pick up permissions that could be granted that I didn't want granted?
Yes, that's true. So if you're doing a learning mode, either with the Pi, with the Maven plugin or outside of that context, yeah, anything it sees, it assumes is intended behavior of the application. So you should distinguish between security testing and your functional testing. That's the short answer. Certainly, if you're doing security testing, I very much recommend then turning Pi on to enforcement mode and seeing whether it blocks the security issues you're finding. Or even not necessarily doing it in enforcement mode, but at least logging the violations it sees so that you can see on the server side, hey, I saw something unusual.
Any other question? So I have one. In the beginning you said the security managers and the security enforcement frameworks, they are often an additional layer of defense. Now you're actually generating the policies for those enforcement mechanisms based on the code. Will you not actually replicate or actually have this bugs or flaws that are already in your software being replicated in your policies then?
In a certain extent. So if your application does have security vulnerabilities, if it's not implementing some sort of authorization check it's supposed to, then you're probably also not testing that fact. As you're exercising your application and running the test, you're probably not doing that authorization bypass. So Pi wouldn't see that and wouldn't add it to your policy. If you are testing that, then hopefully your test is failing and recognizing this was supposed to give me an authorization rejected, and so you're failing it otherwise. So it's certainly true that what this does is going to give permission to what it sees, but presumably what you're testing is the expectations of the application.
So to give one example, for instance, you were talking about the calculator that pops up, so you're executing from Java. If you have a bad program that's actually executing multiple programs from Java, you're allowing them because you actually see the security manager, you're simplifying and you say you can do command line executions from Java. That's what I mean.
Yeah.
Since you're actually really taking the source code as the holy secret.
Yeah, so if you like see a program get executed at one part of the code, then that permission is now granted to the application. That being said, the Java Security Manager does have even more fine-grained permissions than I was really letting on. So when you grant a permission to the Java Security Manager, you grant it to particular jars or even particular classes. So if it sees that this particular class had to execute this code, it'll grant permission to that. And then if there's a vulnerability somewhere else in your application, it doesn't have a record of that permission. And Java Security Manager is also very cool in that it actually checks the entire stack to make sure everything in that stack has permission to this. So you can't even get this problem of sort of, yes, I granted permission to execute code over here, but this other unauthorized bit is trying to use it to execute code. You don't even get that unless that other piece of code also had that permission at some point. So yeah, it depends on how granular you're being when you develop your policies, and Pi does have some sort of customization on how far, whether you want to collapse all jars or look at the individual classes, because obviously if you do get granular, it gets to be a much longer policy. But yeah.
What issues does Pi, what issues do you think Pi can mitigate, and what issues do you think it cannot mitigate?
So Pi being a general framework, it kind of depends on what you're applying it to. And I'm going to, again, speak to the context of the security manager just because that's what a lot of this talk was about. And so that really depends on what permissions the security manager can enforce. So it can prevent path manipulation because it whitelists what files are allowed to be accessed. It can potentially mitigate something like server-side request forgery because it whitelists which host names you're allowed to resolve and open sockets to. It's not going, that particular module isn't going to solve XSS, but if you apply Pi to the CSP module, then it can help prevent XSS. It's not going to prevent authorization bypasses unless you then build a module for your application. So it can potentially work on a lot of defects, especially well-known ones, but it really depends on how you're applying it.
Do you think it could be applied to legacy code somehow? Like potentially to like an applet or something like that that you're forced to use, but you can't get rid of it, you want to lock it down?
Yeah, I mean, and that's exactly what I was talking about with this Struts2 example. Like, if you're running that version of Roller, some legacy piece of code, and you know it's old and probably hasn't received security patches, you don't know if it can be exploited or not, but you definitely want some added layer of protection just because you know this thing is old. Absolutely, like that is one of the things that this can do. Is
What if you didn't have the source code though?
so yeah, this doesn't actually require any source code. You're just dropping jars into your container, and it runs as part of your application. So this is, yeah, very much just running on with your WAR or whatever your application is using.
Other questions? No. Let's thank the speaker again, Dave.
Thank you.